Warm greetings to all students, friends. Very good morning to all of you. Today I am going to deliver a video lecture on the problem, the case of closed coil helical spring. All of you know that the closed coil helical spring is nothing but a tensile spring which is used to find the stiffness of the spring and also what will be the torque developed in the spring and what about the maximum deflection occurred in the spring if a particular material is given for a given spring material. I am taking a problem, the case of closed coil helical spring. A closed coil helical spring of mean diameter of the coil is 100 mm and the diameter of the wire is 5 mm, which carries an axial load of 200 Newton, and the number of wire in the spring is 10 numbers, and the shear modulus of the given spring, we can take it as 1.8 into 10 power 5 megapascal or Newton per square millimeter. So what will be the torque developed and what is the stiffness of the spring, and also what is the maximum shear stress in the spring material, and what about the stiffness of the given spring. So these are the parameters we are going to find in this problem. So the torque developed in the case of closed coil helical spring is capital T is equal to W into R, where W is the applied load in the closed coil helical spring, R is the mean radius of the coil of the spring. So that is equal to, load is 200 into the diameter is 100, so mean radius is 100 by 2, that is 50 mm. So you are getting the value of 10,000 Newton millimeter. Now we can see that the problem is worked out for the data what I have given. So it is 10,000 Newton millimeter or 10 Newton meter. So that is the torque developed in the spring. Then what will be the maximum shear stress? So that can be taken from the torsional equation. T by J is equal to Fs by R, where Fs is the maximum shear stress developed. So T by J is equal to Fs by R. I want Fs is equal to T by J into the maximum radius of the coil wire. So here T is the torque 10 Newton meter or 10 into 10 power 3 Newton millimeter, divided by J is nothing but pi into d per 4 by 32, that is equal to Fs divided by d by 2. If you are working out, we are getting a equation of Fs max is equal to 16 Wr divided by pi d cube. So that is the equation, you will get it. So here Fs maximum is equal to 16 into 200 into R is 50 divided by pi into the diameter of the wire is 5, so 5 cube. So if you are working out, the maximum shear stress will occur as 407.64 Newton per square millimeter. So the maximum shear stress in the material of the closed coil helical spring is 407.64, that is, you can take it as 408 Newton per square millimeter. Then what will be the deflection of the given spring? So deflection of the given spring, delta is equal to 64 W R cube N divided by C d power 4, where capital R is the mean radius of the coil and W is the load applied, small d is the diameter of the wire, N is the number of wire in the spring. So number of wire in the spring is 10. So if you are taking that, you can see that. So this is the equation 64. W is 2 W is 200 into R cube. So here it is 50 cube into 10 divided by C is 1.8 into 10 power 4 C d cubed. That is again 5 cubes. So if you are working out the deflection in the given spring is, you can see that it is the value of 142.2 mm. So the deflection of the given closed coil spring is 142.2 mm. So that is 142 mm we can take it is. Then what will be the stiffness of the spring? So the stiffness of the spring is nothing but the amount of load required to produce unit deflection in the given spring, that is Newton per mm. So W by delta, here W is 200 divided by delta here is 142.2. So if we are working out, the stiffness is coming at as 1.406 Newton per millimeter, 1.4 Newton per millimeter. So that is the given stiffness of the given closed coil helical spring. So these are the unknown parameters we have been worked out. So like that, from the given data, you can find what will be the load to be applied, or what will be the maximum shear stress, or you can find if the stiffness and the height of the spring is given, you can design the diameter of the given closed coil helical spring, and the diameter of the coil also you can design it. So that we can see in the next video. Thank you very much for patient listening. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.